What's up, y'all? This is Hussein Nasser from iGeometry, where we discuss software engineering by example. And today's topic is stateful versus stateless architecture or application. So, in this video, we're gonna quickly describe an example of a stateful application and advantage and disadvantage of those, and an example of another stateless application, and again, advantages, disadvantages of all. So yeah, for this example, we're gonna take an authentication example, because that's the easiest thing I could think of, really. So basically, you would go to your server, authenticate yourself, username, password, log in, and then view your profile. Very simple stuff. Okay, it's really simple. So that's the idea. I'm building an application that actually authenticate me and then views my profile. It does more, obviously, but this is just for the sake of the example here. All right, so let's explore the stateful version here. I have a server here, and I already written my application. So my application has two pages or two services you can think of. It's called login, where basically I visit this page to log in into my application. And to visit this page, I would basically provide, let's go ahead and actually do that. So I would provide server 1, which is basically, let's say it's hosted on HTTP, so server 1 / login, and then I'm gonna post the username and password. So usually you're gonna encrypt this, but I'm gonna use get here. So Bob, and password is, just for the sake of example, Bob1, right? This is it's a very bad password, but yeah, you get the idea, guys. All right, so yeah, so now I just initiated this request. Bob initiated this request, right? And then we're gonna visit the page login. So what Bob will do is, like, we're gonna take the username, password, and there's some code which will basically take the username, password, queries the database, verify that this guy is who he says he is, and then after we get this piece of information that, okay, username, password is cool. So what are we gonna do in this version of the stateful application? And we're gonna set a session variable, or like a global variable, in my server, which is server 1 here. So saying that Bob logged version equal true. So I just set sim variable here in the server itself, changing. So think of it as a state. So one moment he was not logged in, and then the other he's logged in. So now what Bob does is says, cool, now I can, I think, view my profile. So what he does is literally views profile. He doesn't send anything else, just view profile, literally just try to view the profile page. And since we go to the profile page and then go execute that script and says, is Bob really logged in? Yes, he is, because we remembered this piece of information on the server. So I know that Bob is logged in. Usually what you're going to do is some sort of an array or a session variable that tells me that, hey, this user is now logged in using this credential, right? So now, yeah, and we're going to get the view profile and it will be successful. So what is the advantages of this? So the first call I made to log in, I queried the database, I did that, and I stored that state into my server. So next time Bob calls or make a call to view profile, I do not need to query the database, thus storing the state, right? Saving me a trouble of querying the database twice. Cool? Cool. All right. So this is the stateful architecture or stateful application. So where does this break? Now, remember, this variable, this session variable, is stored in the machine. So it's in the RAM, it's in the memory, right? It's in an instance. So if I literally do that, if now Bob tries to access the same application but from another server, he will fail. And the reason is because that server does not have that session variable stored, right? Because we saved it here, we logged in here, we changed it here, but if he logged into the other machine, it does not remember Bob, right? It does not. We did not authenticate Bob on the other machine. So in this case, what happened is we could not scale horizontally. We could not copy and just spin up another machine and make sure that our code works. So in this case, Bob has to call server 2, log in, and then provide the username and password, right? So some of you will say, okay, I don't usually type in server 1 or server 2. I just type the site name, right? So usually how this works is there is another machine here in the middle called load balancer, and what it does is just balances the load. I hope I can rotate that. Yeah, cool. I can rotate that. So yeah, that's what it does, right? So usually this is how it works. So Bob does not know about server 1, server 2. Bob knows about LB or machine 1, right? It's called LB. So Bob makes a call to login LB, right? So let's walk through the same example, the stateful example here with the load balancers where it breaks. So Bob makes a call, login, provide obviously the user password, goes to LB, load balancer just randomly assigns a machine to that to Bob, to the client in this case, and he picks up server 1, and we do the login and we set the session variable, we query the database, and then we return to Bob, hey, you cool, Bob, you can now make a view profile. So Bob nicely make a call to the view profile, but now if he was lucky and the load balancer took him to the same machine, server 1, you'll be good because the logged variable is set, right? So that would be okay. But if the load balancer decided to take him to server 2, the call will fail because he is not logged in on server 2. And that's why, imagine like you would go into facebook.com and you go to the profile and then you refresh the page and you have to log in again. That's not really user friendly, is it? Right? So that's the idea of the stateful application. If you build stateful application, you do not scale, but you save into some calls to the database. So you store the state of the data. So it depends. If you're working with one machine, you can build a stateful application. It's not bad, right? Okay, let's take a stateless example here. By the way, I'm using a cool tool called Glyphy, as you can sew from there. All right, so let's take Alice here. Alice, in the other end, has built or is using a REST, for example, a representational state transfer. And let's focus on the state transfer here. It's very important, right? Right. Focus on the state transfer. We're going to talk about it in a minute. So yeah. So there's a LB, that machine LB, and I'm lazy, so I'm going to copy these puppies here. I feel I can copy and paste it. Ooh, I love Cliffy, man. This is really cool. All right. So yeah, Alice, same thing, right? Alice makes a call. Says, hey, LB, log me in. There was a tool called log me in back in the 90s. I used to use it. Come on, mate. Come on, mate. Okay, LB, log me in. So what this application is, oh, we forgot our database, man. We forgot our database. So the database is connected, obviously, on the two servers here. What happens here? What happens with a stateless user pass, right? Jesus. All right. So yeah, Alice makes a call, user pass, LB, it takes it to the server 1. The application here is written slightly differently, right? Slightly different. So Alice makes a call to login, LB takes it to server 1. Doesn't matter really here in the stateless application. Now login, actually what it does, it does not store any state, right? What it does is say, okay, user pass, let me query the database. Alice is lit, all right? She's cool, let her in, but let me do one thing. Let me send Alice a token so she can communicate with us using this token, right? Look at that. Woo. Oh man, this is just awful. All right. So the server sends back a token. It's usually a very long ass, token ID, right? And you can use that. And now what happens is here, now Alice has a token. It's a very long token, right? And this Alice with each request is responsible to send the token with her. That is cool. What will happen now if I do view profile? Remember, she cannot just do that. She has to send in a token. Right? And the token is ABC, whatever, right? Cool. So she got the token. She's sending the token now. LB will decide to go take her to server 1. Now the view profile function or the script or the service will take the token, and guess what? It has to query the database to verify that the token is cool, right? It doesn't have to be the same database. It could be another intermediate database, right? In-memory database, something like that. But it is a persisted store, right? Usually tokens has also some expiration, so you cannot use this token forever. You can use it, hey, use this for 30 minutes, and then, sorry, you have to request another token. So view profile, make a query to the database, make that trip, make that cost, right? We are incurring an extra cost, but what do we get here? If I view profile from server 1, I'm cool because I can view the profile. If the load balancer hit another server, I'm also cool, right? Because the token will always get authenticated in each server. It's the same thing. We're gonna hit the database eventually, right? It is like as if I am re-authenticating myself with each call, but it's a soft authenticate. Does that make sense, guys? All right, so this was like a quick explanation between stateless and stateful. So stateful, you get less trips to the database, so it's kinda I would say faster the backend, maybe, right? But you cannot just scale it as easily, right, horizontally. But with the stateless, which is example REST, right, we are transferring the state from the client to the server. Does that make sense? Transfer, right, token, and then bring it back, right? So we can scale beautifully here, but there is always a cost at the back end of making extra calls to the database to re-authenticate or to re-pull this information, right? That's why with stateless, you'll hear about the caches or level of caching. There's a lot of caching going on there, but you have to do it in a very smart manner. Hope you guys enjoyed this episode. Please subscribe if you like this video, where we explain a lot of concept in software engineering here, and we're gonna see you in the next one. Have a great day.